Hello, this is Daniel, and I'll be showing you what I have so far of the Dream Guard game. Every asset is still a placeholder, so do not expect the game to look like this. Anyway, uh, what we have right now is some simple AI that is going to choose which target to follow and then follow it. So right now it is choosing to follow the green target, finds its path, and goes there. How it chooses the targets based on this attraction value and the distance between the targets. So right now I have green attraction set to 500 and red to 20. If I increase red, say to 200, it should follow red. If I get the green one a bit closer, then it decides to go to the green one again. So basically it is lazy and it likes stuff. So it measures laziness against how much it wants to go there and decides where to go. Now, to find the path, first let's hit play and then pause. See the squares here? The game grid script, there's this script right here, um, measures the size of the game world, and then it takes, it's in the game manager, and you can see here node radius and node distance. So node radius is the size of each square, and node distance is this void between squares. You don't really need a node distance, but it helps to make sure there's no conflict between two squares where the object is, so a little distance helps avoid bugs. But if you're like super careful with your placement and stuff, you can choose not to have no distance. But you have a little more precision, but I find it better to be a little more safe. Anyway, with this game spliced into a square, so turned into a square grid, the algorithm will then look into, so with the pathfinding algorithm, this one, it's going to look into each square and determine which one is closer using this find path method. So it gets first it gets the closest node to the starting point and the closest node to the target, and so that's basically saying I'm gonna go from this node to this node. It makes a list where it's going to store every node it's checking, and then another one where it's going to store every node it decided it's part of the ideal path. And then then starts adding nodes to the open list. It adds all nodes around the current node, so the last chosen node, and the first one being the actual node where the player is. The last one is going to be the node where the target is. And as long as there's something in this open list, so as long as the size of the open list is bigger than 0, it's going to run this code, which basically says check every node around you, figure out if it's the best node. First, add every node around you to the open list, then check each one, find out if it is the best node. If it is not the best node, get it out of the list. And if it is the best node, repeat. And if it does that until it gets to the target, it will get its final path, return, which means it stops doing everything. It gets out of the function, the method altogether. But if it doesn't, so it's going to add and remove every single square. Be sure that it tried every possible path, and if there is no path, it's going to return no. Which means way to the target's blocked. There's no way to get there. And yeah, these are just like other methods that I use to get this one to work. So yep, that's basically it. That's the game so far. A long way to go, but it's something.